So I guess I just want to talk to you guys about like scalable web architecture. So operations is something I'm kind of interested in. Worked on it at Onshape. Also done a lot on the side with deploying server stuff. This is something that you guys are probably, you don't have to touch if you're like Jim and just do iOS. You're probably not gonna have to worry about it. But even in interviews, people still ask you some questions. So it's good to know what's going on.
Yep, I had an iOS interview today. They asked me what the database was doing, and I was like, I know.
Yeah. So it's always good to know what your technology touches. And this talk I hope to give you guys a touch of like, what's happening when somebody sends a request, and a lot of us have built basic websites or static websites, and those are cool but pretty simple. So there's a lot that goes into getting it to a much larger point, and also being able to do much more advanced functionality. So I'm going to talk more about like what happens when you're building a medium to large scale application, what kind of concerns and technologies you're going to be working with. Are you hearing us okay, Kevin?
Right.
All right, good. So this is just a review. I know like people like John and Haley might not have known what this was. Most of you guys are CSE. So does everybody know what happens when you type a URL into your web browser?
Magic.
Yes, magic. Is that? Yeah. So basically, do you have a DNS server? Goes out, asks, hey, I want to go to Google.com. And then the DNS server goes, hey, here's this IP address, that's where Google is. Then your little magic happens with the routing. I'm not going into that. Then you could do a whole talk just on routing itself. But then, your client goes, all right, I'm talking to this server now, and the server, responds with the web content. So that's the simple interface from either your iPhone or your Android or your web browser to the server. What happens next? So in a basic web application, what happens next is you have a web server, you have like Nginx or Apache handling a request and patching them through into an application. The application can pull stuff from the file system if it needs to send static content back. And then you have your database. This is a really crappy picture. You can tell because it's got like a Windows 94 picture, but I didn't want to make it from scratch, and I found this online. So this is your basic web application. This is something you're going to do in Hackathon when you need to handle requests. This is something that we do for clients too. As a client, when they come in, they don't need anything much more advanced than this, depending on their circumstances. So what happens? You start reaching scalability problems. What happens? You start getting slow, or you need added functionality that just you can't do on a regular one server. So what happens? Your database gets too slow. You're going to have concerns. You're going to have you're going to have to start replicating a database or caching some of your queries, or storing like large objects in memory or in RAM, so you don't have to do a network request and do a query, that kind of stuff. And then you also have your application that's handling the request itself. So if you have thousands of requests coming in a second for different information, not only is your database going to get hard, but eventually your the instance that's handling those requests is going to start getting bogged down with CPU. So then there's two different ways to go about solving that. You can either scale out, add more web servers, or get a faster processor. The typical approach is to get a faster processor, or the classic approach, I should say. But more and more people are getting better and better at making it so we handle distributing along different nodes. And then content, this is pretty classic, but people, I don't know if anybody else has had this, maybe it's just because I'm more operations inclined, but people ask you like simple questions, like what's a content delivery network, or how do I get static content to clients? And do you guys know what content delivery network is? Yeah. So I guess with this talk, if I'm going over too many details that you guys already know, feel free to be like, go next stuff, and if there's something that I'm glossing over, feel free to ask questions. This is something, I'm by no means an expert in everything that I'm talking about. There's tons of stuff out there. And if I make mistakes, please correct those too. Or, for the audience's sake as well. So here's an example of something a little bigger than your classic, than this guy. So I just pulled this off of, this is like a recommended stack for building an application on AWS. You can see inside here you have an elastic load balancer. which is basically just handling requests, sending it to multiple different servers. And then you can see in here they have the database, caching, you can see different database, a lot of different technologies. I'm going to run through these all at once, but I just wanted to show you this to kind of give you an overview of like what happens when you start adding more. You start getting more and more complex, right? So there's a ton of different layers in here that the systems have to work together. How do we connect these systems together? We use service discovery. There we go. So there's tons of different ways to do this. I'll get into a few. But basically, you have a web server and it needs to find out where the database is, right? If you have 5 databases, it's no longer a hard-coded value. You need something to let it you need something to connect it better. So what do you have to worry about? You have to worry about scalability, updating, and you also have to be able to add and remove servers. If servers go down for maintenance or they crash, you need to be able to say, hey, don't route my traffic to this web server anymore. It's not responding, or it's not connected to our network. So how do we do this? Actually, sorry. So the goals with the registration, you want availability, so you want your registry to be up as much as possible. Because if your registry isn't up, then services can't find each other to talk, right? You also need to handle failure. So what happens with one of the nodes in the registry fails? This is a classic problem of uptime versus accuracy versus, I forget the 3R. But basically, if your node fails and you're trying to get requests, does it fail gracefully? Can you still handle requests even if one of your registers fail? And then what happens when a node that's in your registry fails? So what happens when your web server stops responding? It's not going to tell the registry, hey, I'm not responding anymore, right? So you have to have a check-in mechanism or something where if there hasn't been availability, check-in or update, or either you're pinging out or it's pinging in. You can't just assume that something's up and running. You also have to worry about ease of use. There's a ton of different solutions out there, and it's definitely something that's custom to what you're building and what language you're using too, because language bindings make things a lot easier. So here's a couple tools that people use for service registration discovery. Zookeeper is a very popular one. It's mostly Java. A lot of people use it with Java. I think it's Java based. It's owned by the Apache Foundation. It requires language bindings, so it's if your language doesn't support Zookeeper, or you don't have the libraries aren't that well developed for your language, then you're probably not going to use Zookeeper. There's not like a queryable API or anything like that. The other thing to think about, I guess I didn't explain this before, but the basic premise of a service registration is you have almost think of it as like a tree where you have subdomains or a file system. So your application, when it's trying to find an app, it will go into say your root of your node has dev, staging, and production, right? So say you have a development web server, and it knows it's a development web server with something in its configs. Then when it tries to find a database server to talk to, it wants to talk to a development database server. So it'll go to go root/dev/database, wherever you set it up, which will then return an IP address or connection information. Doozer is another one. Was very popular at one point. It's not actively developed within the last couple of years, and if a service fails, like I was saying earlier, it has trouble it doesn't have a sense of a failed node. You have to manually delete it, so you have to write management scripts for that. etcd is a new thing that's coming out. You guys might have seen it. Some of the Arcos people, the Core OS people were here and talked about it. Basically, that lets you do discovery via a JSON API. So like I said before, Zookeeper, you needed a language. You needed language bindings for your development. But with etcd, you can kind of just send an HTTP request, and you'll get JSON response back. So basically any language can do that. The other way to do this is then there's tons more. But another way that's fairly popular, especially with like more static or when you're not spinning up new servers and destroying old servers, is to use DNS. So Netflix did this for the longest time. They started rolling away from this. But the idea is if you want a database server, you go to like database.dev.netflix.com or something like that. All right. So once you have your registration, so you have your basic web servers, right? And you're routing between them. You guys are all familiar with the concept of load balancing. So I'm going to kind of gloss over this a little bit. But basically with load balancing, you're routing your traffic through different nodes to get higher availability. There's a crap load of algorithms you can use. Most of them are dependent on your use case or something like where I was working on Onshape, our routing and load balancing is a lot different than somebody because we have much longer sessions. You build a modeling session and you're connected to the server for minutes, hours, whatever. That requires a much different form of load balancing than say Snapchat, where you send an image and then the image, you upload an image and then you download an image. It doesn't really matter which server you're connected to in between those two activities. So your web servers, there's monolithic and then there's service-based web servers. The monolithic is, if you guys imagine classic enterprise, you have one Java application that gets deployed. It's huge, it runs, and it does its thing. Service-based is more like you have a web application that handles sign up or registration. That's almost getting into microservice. There's a big tier between, you guys have probably heard of microservice, but there's a big line between microservice, service, and then monolithic. We can talk about that later if you guys want. But there's just some popular languages built with them. Databases, you guys know databases, but when you're choosing, SQL, NoSQL, either can be scaled